Hello, Assalamualaikum. My name is MAT183 bin ROZLI. Today, our group will assign that we need to create a video regarding a topic from MAT183 Calculus 1, which is application of integration. So now I will introduce our team members, which is myself, MAT183 bin ROZLI, Muhammad ZAKWAN bin ZULKEFLI, Syed Nur Muhammad AL-BUKHARY bin Syed HASSAN, Muhammad IQBAL bin Rahmat, and Ali ZAKWAN bin Ali HANAFIAH. What is integration? Integration by parts is a theorem in calculus that connects the integral of a product of functions to the integrals of its derivative and antiderivative. By simply integrating the product rule of differentiation, the rule can be derived in one line. So now let's get to the problem statement and solution. Alright, we will begin our presentation with an example question and the solution. The question is from MAT183 Calculus 1, March 2017. Question number 29. The shaded region in figure 1 is bounded by the curve y equals to x squared plus x plus 1 and y equals to negative x. Okay. 29.1. Find the coordinates of A and B. The second question is find the area of the shaded region. So basically there are a few keywords that needs to be highlighted, such as the bounded by the curve y that's available on the diagram, y equals to x squared plus x plus 1, and the other one is y equals to negative x. The first question is we need to find the coordinates of A and B, while the second question is we need to find the area of the shaded region. We're moving on to the solution. Okay, so this is the solution of the 29.1. So all the steps are divided by two steps. The first one, we need to write the equation given and differentiate both of the equation. So basically the equation are already given on the question, which is y equals to x squared plus x plus 1, and the other one is y equals to negative x. After we differentiate the equation, it will become 2x plus 1 and the other one is negative 1. And we need to find each main point, which is A and B. We need to find the point A. We need to use the y equals to mx plus c as the formula, and we will get negative 1 equals to 2x plus 1, and then after we evaluate, negative 1 minus 1 equals to 2x, and then negative 2 equals to 2x, and then negative 2 per 2 over 2 equals to x, and then lastly negative 1 equals to x, and then y equals to negative x, and then we substitute with this x and this and negative 1, and then we get this, and lastly y equals to 1. And how we need to find the point B? Y equals to x squared plus x plus 1. The equation is right here. As you can see, we need to apply from here to find the point B, and then y equals to negative 1 squared plus negative 1 plus 1. After calculation made, y equals to 1, and then x equals to 0. So B is 0, 1. So that's the end of the question 29.1. We move to the second question. So the second question is we need to find we need to find the shaded region, find the area of the shaded region. So all we need to do is take the equation that we calculate earlier, which is this one. This is for A and this is for B. We divide the steps into 3. The first one we need to do is identify the boundaries, and we need to set it up, the integral, and simplify. So this is the formula that we need to use, and then we apply using the previous equation that are given on the question, which is x squared plus x plus 1 minus negative x dx. And then after we do some calculation, we get x squared plus 2x plus 1 dx. Okay, the second step is we need to proceed with the integration substitute upper and lower bound. This is the upper bound. As you can see, x cubed over 3 plus 2x squared over 2 plus 1x. This is the sorry. And then we use the find the lower bound, 0 cubed over 3 plus 2 multiplied by 0 square over 2 plus 1 times 0, and then negative 1 to the power of 3 minus 3 over 3 plus 2 times negative 1 square over 2 plus 1 times negative 1. And lastly, we need to evaluate the value, and 0 minus negative 1 over 3, and then we got 1 over 3 unit square. So this is the final answer.
Hello, Assalamualaikum. My name is Syed Nur Muhammad bin HASSAN. I'm from class 4G. I'll be discussing and doing the question 31. The question is using share method. Find the volume of the solid generated when the shaded region is revolved about the x-axis. Okay, the working process will start with y minus 0 equal to y. Top is y, bottom is 0, and then y in the bracket of y equal to 2 minus y square negative y. Y is the right, left, and then we need to find the volume. 2 pi this integration of 2 and 0 y in the bracket of 2 negative y square plus y dy 2, and then we need to multiply every this, and then we get this 2y negative y cube plus y cube y square, and then with this integration we need to plus 1 plus 1 plus 1, and then okay, then we got this 2y square, and then negative y power 4 over 4 plus y cube over 3, and then we need to cut 2 y square, we need to cut 2 and over 2, and then we got y square over y power 4 over 4 plus y cube over 3, and then we multiply every single, then we need to insert into y, and then we get the bracket 2 power of 2 in the bracket 2 power of 4 in the bracket 2 power of 3, and then we simplify, and then we get 4 minus 4 plus 8/3. Then we do the last simplify, and then the answer, the final answer will be 8/3 pi unit cube. Okay, that's all from me.
Assalamualaikum, my name is Iqbal. I will continue on to the next question. And for my question, which is question 30, Roman 2. This question is actually quite different from SYED. Because in this question, they want me to find the volume of the solid by using the washer method. Let me highlight it for you. By using the washer method. And then the next tricky part is they already given me the rotation point or the axis of revolution, which is x equal to 2. So let me draw it down. Where is the rotation axis? It is here actually. So the solid will rotate at here, and then to complete this question, I have already put down the formula to complete it. So in this formula, we need the f function. So f function actually is the outer layer. So in this case, in this question, the outer layer is here, this straight line. However, for the g function, which is the inner layer, it is actually the curved line, which is here. So let me show you the working step that I've already put it down. So this is the solution. Okay, first thing first, let me show you. I've already put down the formula, and then after that I put down the information that already been given here, and then I will focus it more on the first part. So on the first part, I need to eliminate the open bracket and the power of 2. So how do you do that? Well, by expanding it. So after I have already expanded, I need to simplify it. So, and the first part, the result is pi integrate 0 to 2 4 plus 4y plus y square minus 2 minus positive 2 minus y square, and then power of 2 dy. So next part is we need to solve this part here. It is just like the same before. We use the same procedure. We expand it. After we have expanded, we simplify it, and then after more simplifying step, we need to simplify it so it is more manageable, so that we can integrate it more easily. Okay, after we have come to this point, which is we cannot simplify it more, so we need to integrate it, and this is how I integrate. So it will be like this, pi negative y over 5 to the power of 5 plus y over 3 to the power of 3 plus 2y square plus y integrate 0 to 2. So how we do this? We simply just exchange the y value to the 0 and 2. So here is the part where I already changed the value of y. So here is the for the number 2 part, and this is for the 0. How did I get the 0? It's actually quite simple. You just change the y to the 0, and in this case all this number actually have the variable of y. So in this individual, all will be multiplied to 0, which will end up with 0. And then after I have changed the y value, we need to calculate it, and then after I have calculated, I get the end result, which is here 184/15 pi unit cube. So that's it. That's how I do it. Thank you.
Assalamualaikum, my name is ALIF ZAKWAN bin Muhammad Ali HANAFIAH, and I'm going to solve the question number 32 Roman 1. Consider the shaded region R enclosed by the curve y equal to 2x with the power of 2 minus with x with the power of 3 and x-axis as shown in figure 3. Roman 1, using shell method, find the volume of the solid generated when the shaded region is revolved about the y-axis. The shell method formula is integral a to b 2 pi multiplied with radius and height and multiplied by height dx. The radius is y equals to 2x with the power of 2 negative x with the power of 3. Now we're going to put the data that we get into the formula. Integral 0 to 2x multiplied with 2 pi multiplied by 2x with the power 2 minus with x with the power 3 dx. And now we're going to rule out the constant, which is 2 pi here, and then we're going to write it like this. After that, we're going to use the antiderivative, and the integral will be put in the back. And now 2 pi, the x with the power of 3, the power of x will be added by 1, 2 over 3 minus with 1 over 4 x with the power 4, and then the x we will replace it with the 2 in here to here. Same thing goes here, and after that we're going to minus it with the same thing, except the 2 will be replaced with 0 here. Alright, after that 2 pi 2 over 3 multiplied with 8 minus with 1 over 4 multiplied with 16 minus with 0, and now the answer that we get after the calculating it is 2 pi 4 over 3. After that we're going to multiply it, and we will get the final answer 8 over 3 pi, and that's it, how we get the volume of the solid region using the shell method. Alright, thank you. That's all from me. Have a good day.
So basically here we are going to find out Rx is equal to what? So here is Rx. So basically Rx is equal to y, and y is equal to square root of x. So we want it in terms of x, so we will use square root x. So for that, after we calculate this, and then we will integrate this function, and then we will get pi 4 squared over 2 minus 0 squared over 2. So 4 over 2 is 16 over 2 minus 0, and 0 squared over 2 is 0, and so the last answer is 8. So this is the conclusion of our group project. With that, thank you.